All right, so today we're learning a concept called two-way tables. In 6.1 and 6.2, we were comparing two sets of data values. If you remember, one example was television size, screen size versus the price. What we found was that was a positive relationship. As the size of your TV increases, what happens to the price? It increases. So comparing values, okay, to each other. That's what we've been doing with scatter plots. Well, two-way tables is another way to draw comparisons between categories of data, okay? So it displays two categories of data collected from the same source. And in today's lesson, it'll be the same survey. All right, so each entry, each tally mark in a table is called a joint frequency. Then the sums of those rows in the table are called marginal frequencies. All right, so get those filled in. You guys have them marked down? All right, so in example 1, we're just learning how to read a two-way table. So I'm going to ask you a couple general questions based on this table of students who studied and did not study, and students who passed and failed a test. It says how many students in the survey below studied for the test and passed. So what the two-way table does is it gives us this category. These students studied and these students passed. So the number that is in both column and row would represent the number of students who studied and passed. Okay? So to answer that question, I would say 21. Okay? Now it's going to ask me how many students in the survey below studied for the test and failed. How many studied and failed? 1. So again, it's category, studied. Okay, but now it's failed, studied and failed. That would be only 1. All right, so what conclusion could I draw if I were comparing just these two categories, okay? And the interpretation is not 21 students passed and 1 student failed. That's not what I'm asking. I want you to try to kind of read into these results a little bit, all right? Think of the topic here. Could you give me some kind of conclusion or interpretation, Mason?
The more you study, the more chances you have to pass.
Perfect. Okay? This is a test, all right, where we could pretty much bank on it. If you put in the effort, you will pass. Okay? And thankfully, that is true for a lot of tests that you take, isn't it? But there are certain tests that just because you study, just because you read through the information, is that a guarantee that you're going to pass? No. Okay? It's never a guarantee. There's definitely other variables. All right, so that was a great interpretation. That's exactly what I was thinking too. All right, how do we do on example 1? Just kind of looking at the columns, okay? So in example 2, we're going to calculate something called marginal frequencies. Then we're going to interpret those, okay? So a marginal frequency is a total of the rows and columns. So what's going to happen is we're going to kind of extend out our rows and columns by 1 more category. This is not going to be on, like, as a part of your template on your test. This is on your midterm also. You're going to need to know to do this. If it needs marginal frequency, you're adding a row and a column. Okay? You're adding a row and a column. And what you're doing is you're now calculating a total. How many students overall passed the test? How many? 23. Because whether they studied or didn't study, they still passed. So 23 students studied and passed. I'm sorry, just passed. How many students failed? 7. Okay, so before we do anything in that bottom block, let's come over to the columns. All right, so we're looking at the studied column. How many students total studied?
22.
22. And how many did not study?
8.
8. And if I've calculated this correctly, the total of my column and the total of my rows should be the exact same number. Okay, what's 23 plus 7? 30. And what's 22 plus 8? 30. So the total needs to be the same, which it is. All right, so I have done this correctly. All right, so the interpretation is this. I'm going to take each one of these categories, each one of these sums, okay? And I'm going to say what these numbers mean, okay? Because I don't have room over here, I'm just going to come over on the left side in this blank space, and y'all can do the same thing. 23 students, what? What does the 23 stand for? Passed. What does the 7 stand for?
Failed.
7 failed. Okay. What does 22 stand for?
22 studied.
22 students studied. How many? Oh my goodness. 8 did not study. Okay, so we're basically saying what those totals mean. Okay, 8 did not study. And what does the 30 stand for? 20 students took the test. Or were surveyed, but I kind of like took the test. Okay. All right, so do you see how we did our interpretations? Okay. Our interpretations were based on our totals. All right, how do we do on that?
It's easy.
Did pretty good?
I just gotta remember
All right,
that
this
part.
next one, for some reason, this next one kind of messes with my head a little bit more. All right, but we'll get it. Okay, so I need to calculate marginal frequencies again. All right, so I want you to go ahead and do that. So again, this is what I'm drawing here. This is not going to be on your midterm. You're just going to need to know this is what you do to calculate it. 40. Let me do it in red. 40,
Oh, equals.
36, 25, 51. All right, and what number goes in the bottom right?
76.
76. And is that my total for my vertical and horizontal coming together? Okay. All right, so now the interpretation, okay, 40 students what? Attended what?
Football. Dance.
The dance, okay, so here we go. 40 students
I can't spell this.
attended the dance. Okay, I'm going to combine did and did not. How many did not? Did not, yes. 36 did not, yeah. All right, I'm just going to say 36 didn't because I'm running out of space. Okay. What about 51? What does 51 mean?
People that.
Oh my goodness, I cannot spell today. 51 students attended what?
Football.
The game.
The
The game. Attended the game. How many did not?
25.
25 didn't. Okay. All right, so we're literally saying what these numbers mean, okay? So because that was football game, we're saying 51 attended, 25 did not. Now, the 76, I kind of want to go back now because I can't say 76 what? Because of the two categories, I can't say 76 went to the football game. That's not true. So I'm going to say 76 students were surveyed. 76 students were surveyed. Okay, they were asked. All right. Now, there's definitely a chance that some maybe went to both. Okay. All right. So that's marginal frequencies and interpretations. All right. On this next one, I almost wish that I hadn't given you the template because I feel like the template in and of itself is a little confusing. So I am going to get you started on it. On your midterm, don't quote me on this, but of course I'll clarify it before we take it. I don't believe you're making one yourself. I think you're doing the marginal frequencies. Actually, I'm like 99% sure that's what it is. Okay, but again, I'll clarify. So, but I think there's definitely still some value here. So we're going to do it, okay? But I am going to give you the category. Age goes on top, okay? And then riding the bus and not riding the bus. So we'll say,
So we need to draw that box.
Rode the bus instead of ride the bus. Rode the bus.
ride, it's present tense. How many are currently participating in that program? So we'll say bus or ride and
Yes. Right there in the line. I don't know.
not ride.
No, never mind. Never mind.
Okay, so here we go. All right, and then what are my three categories of ages?
12 to 13.
12 to 13, 14 to 15,
16 to 17.
16 to 17.
I'm on drive.
Okay, and then we're going to have totals. Actually, we're going to talk about that in a minute, Michael. All right, and then we have totals down here. So what we do now is we come over here to the data. This is the breakdown. This is important, okay? So how do we come up with those numbers before? We went around and asked kids, right? Hey, did you go to the school dance or did you go to the football game? And we did a tally. That's what we were talking about at the beginning of the lesson. Each one of these tally marks is called a joint frequency, okay? Then the sum or the total, that's my marginal. So how many kids, based on this survey, ride the bus ages 12 to 13?
24.
24. So I come over here, I see 24 tallies. I'm going to say 24 in that block of 12 to 13-year-olds riding the bus. How many do not 12 to 13-year-olds? 16. So how many total would that be?
30, 40.
40. Okay? So what I want you to do now is fill in the rest of the table, including the marginal frequencies. What does marginal frequency mean again?
It means like all of them.
It means your category totals. Marginal frequencies are your category totals. Okay, so now we've got 12, 13 makes 25.
14 plus 21 makes 35.
Yep, 14 plus 21 makes 35. And then I've got my totals all the way across. How many students total ride the bus? 50. And don't ride?
Whoa.
46.
Nope, 50 again.
It's supposed to be equal, myself.
Yep. And then when you add both the column and the rows together, this is 100 and this is 100. So I know, based on the fact that both of those sums are the same, that my two-way table is calculated correctly. Okay, so if they add up to different sums, you know that you added something wrong. All right?
You talking about for like the live box?
Yeah, that last box that's in red. Okay, so now what I'm going to do is I'm going to take this one step farther, and I'm actually going to calculate percentages. Okay? So I'm going to take this information, and I'm just going to, I need to rewrite on this last box. Do you guys have one more box or no?
They use that box.
No, go flip over. You don't have one more?
We were supposed to.
But what's that above?
That's the box, but he used the other one because
Ooh.
he didn't write it.
Wait.
Okay, so don't have another one? That's okay. Just look up here. All right, so I'm going to rewrite my numbers. All right, I've got 24, 12, 14, 16, 13, and 21. Okay, and it says, what percent of students ride the bus? Okay, so I'm going to look at the age groups. All right, now, how many students total in this age group did we say ride the bus?
40.
40, okay? So 24, if I take that number and I divide it by 40, it's going to give me the percentage of the 12 to 13-year-olds who were surveyed. It's going to give me the percentage who ride the bus. So, and then I'll divide 16 by 40. But guys, whatever this one is, I just can like subtract that from 100 to find the other one. Okay? So I'll show you in a minute. 24 divided by 40. So what's 24 divided by 40? Okay, so we can divide it. We get a decimal and we can change that to a percentage. 24 divided by 40 is 0.6, which would mean 60%. So this means 60% of my 12 to 13-year-olds rode the bus. Well, just by, common assumption, if it's out of 100%, if 60% ride the bus, how many percent don't ride the bus? 40%. Okay, it's got to add up to 100. So really, I only need to calculate one. Now, how many 14 to 15-year-olds were surveyed?
25.
Only 25. So guess what I'm going to divide 12 by? 25.
48%.
Yep. 12 divided by 25 is 0.48, which is 48%. Based on what I just said for the last category, can someone tell me what percentage did not of this age group? Josh? 52%. All right, you see what we're doing? We only have to calculate one of them. Now, 14 divided by what? What do I divide 14 by? 35. So I always divide by the total. And 14 divided by 35 is what? What is it, guys? What's 14 divided by 35?
40.
Okay, it's going to be 40%. Okay, so if 40% do ride the bus, how many do not?
60.
So why in the world, okay, why would I calculate all these percentages? Well, first of all, it told me to, okay? Then now I can use them to answer this question. We're always looking for some kind of a trend in the information. Is there a relationship between age and the percent of students who ride the bus? So now that I have these percentages, do you see anything that's happening as my age intervals increase? Do you see anything that's happening to the percent of students
It's going down.
who ride the bus?
It's decreasing because they probably have cars.
Right? Okay. So to answer this question, I'm going to say, yes, there definitely is a relationship. As age increases, students are less likely to ride the bus. Now, if you say that a little different, that's perfectly fine. All right, I'm not looking for you to kind of read my mind on this. It's just less likely. You just need to kind of be close. So if you're saying they're driving more, that's perfect because I see that you understand what we're talking about. To ride the bus.
12 to 13-year-olds be younger than that.
Yeah, of course. And that definitely makes sense. Okay, so that's it for 6.3.
They do rough